Alright, so looking at graphing and transformations. So in general,
Excuse me, can I get some calculators?
you sure can.
Thank you.
So for any function, where those numbers are, they have a different effect on the graph, or the way we describe the graph. And as you've seen with those truncuses in particular, some dilations from the x-axis and dilations from the y-axis, depending on what those numbers are, can have the same effect. So when you're looking at those numbers, depending on where they are, is how you describe the transformation. So for any function, you've got some number times the function, then this stuff in here, depending on that number. So the dilation one we're talking about is the n and the a. So depending on where that n and that a is, that number depends on. So if you're doing something multiplying the x before you do the function, that's a dilation from the y-axis. But if you do the function first and then multiply it by some number, it's dilation from the x-axis. All right, so the transformation from y equals just fx are the following. Oops. So the a out the front here, so you've done your functiony thing, whatever that might be. It might be squaring, cubing, whatever it is. You've done that first, then you multiply it by some number that then makes the y bigger, so that's a dilation factor. Ooh, got to spell properly. Factor a from the x-axis. Whereas the n, so the n, that's inside the function, so we're multiplying this stuff, the x, we may have translated it, we'll get to that, but we're multiplying that before we then do the function. So when that happens, again, it's a dilation. Factor 1 on n, so it brings it closer to the y-axis. Now you might think, like so it's the difference between if we've got something like this, or have we got something like this. Alright, so this one here, we're timesing the x by 2 before we do the function, the squaring. So this one's a dilation of a half from the y-axis. Alright, so half from y. Whereas this one here, we've done the function, we've done the squaring first, then we've timesed it by 4. So we're timesing it after we've done the function bit. So this is 4 from sorry, not 4, 1/4 from x-axis. And just to complete all of that, so say I'm looking at the point 0.11, for example, depending on which way we look at it. So normally the 0.2 here is at 1/2, and the point that's 1/2 there and 1/4 are 1/2 is at 2, 1/4 is at 4. So normally we've got, that's our 1 on x squared. But when we look at this one, 1/2 from the y-axis, so if we put x equals 1 in here, 2 times 1 is 2, 2 squared is 4, so it's 1/4, which is down here. Alright, so it's like we've moved that point to there. 1/2 from the y-axis. Here, we square the 1 first, 1 squared, and then 1/4. So 1 squared is 1, and then 1/4, so that's bringing this one down to there. So for our truncus, we get the same result, depending on, so we get something that's like this. Alright, so it's the same result, just described in a different way. Alright, and so sometimes we get confused about that.
So if the 4 was outside of brackets on the second, like outside of brackets of the whole,
You could have a,
would that be a factor 4 from x-axis, not 1/4?
it'll still always be 1/4, because it's after, you're doing the times by 4 after you've done the function.
Right.
Our function this time is squaring.
Right.
So because we've squared first, then times by 4 from the y-axis. Here we've times first, then we've squared it. So because we've times first, it's from the y-axis.
Yeah. So where would the 4 have to be for it to be? Would it be 4 over x squared if it was just a factor of 4?
Yeah.
Cool.
Yeah.
Yeah.
So if you don't think of this one as being, you can think of this one as being 1/4 of times 1 on x squared.
Yeah.
So you got 1/4 of this, whereas yes, what you're saying, that's not going to bring it down, that's going to take it up. Again, that's like 4 logs of. Right, so that number's been done after we've done this.
Yeah.
Alright, so, yep, often it's confusing to keep it in mind as to what it does. And of course this one here, when we multiply before, the factor's 1 over it as well. Alright. A couple other things in there, there's a couple of translations. So, a couple of translations. Alright, what does the H do? Translates in the, which direction?
The X direction?
Yep.
Oh, yeah.
That's the word.
Yep, in the X direction, and the K? It's in the Y direction. All right. Now, depending on what you're given to sketch, some of these things can take care of themselves and others don't. So for example, I'm going to do a hyperbola. So in the case of the hyperbola that, that I'm going to do, I'll write it up first. So here's our hyperbola, it's 4 over x plus 5 minus 3. So there's some transformations there, there's a couple of translations, and then there's a dilation. So sometimes, in this particular case, the dilation, when we sketch it, the dilation is going to be taken care of in what we find. So, what do we need to graph a hyperbola? What things do we need? Someone mumbled asymptotes. So, the question is, what are the asymptotes? What are the asymptotes related to? Asymptotes are related to the
Limits. No.
translations. All right, the translations. So asymptotes for the standard ones.
0 and 0.
Right, normally the asymptotes are the axes. So if you translate, those asymptotes are going to move. So these numbers here are the ones we're interested in for our asymptotes. So we'll have two asymptotes, x equals what and y equals what?
-5 and -3.
It would be -3 and the x value is which way does this translate?
Left.
Left. So if it's going to the left, that asymptote's moved from here to down here, which is -5. All right, so let's draw in our asymptotes. There we go, there's -5 down there. -3, there it is there. All right. Now, there's also a dilation, but in this case, when we're sketching graphs, we need to show all our important points and our important things, or our important features, I should say, not necessarily just points. Some of the features, as in this is the case, are asymptotes. So, what do we know about hyperbolas?
There's 2 of them.
There's 2 bits to it. Our standard one's here and here, unless there's been some sort of reflection, which there hasn't been. But if it's here and here, the bit that's here, it's going to cut through the axes. So we can find some intercepts. All right, so let's find the Y-intercept. The Y-intercept occurs when x is 0. So we've got y equals 4 over 0 plus 5 minus 3, which is 4/5 minus 3. How many fifths in 3?
3, 15.
15.
Oh,
So
wait,
4.
3 whole ones.
3 holes, how many fifths in 3 holes? There's 5 fifths in a 1, so there's got to be 3 lots of 5, 15 of them. So 4 minus 15 is
11.
negative 11 on 5. So I go, where's negative 11 on 5? Well, it's a bit more than negative 2, isn't it? So there's negative 2, so there's negative 11 on 5 right there. Alright. I'll just put a little, so that's 0 and negative 11 on 5. It's got to be X-Intercepts. How do we find them? So X-Intercepts, Y is 0. So we then get 0 equals 4 over X plus 5 minus 3. First step. I've got to rearrange to get X. That's the first step.
Add 3.
Add 3. 4 on X plus 5.
Divide by 4.
Divide by 4. Alright, yeah.
Takes 5. Wait.
Oh,
Now what?
you could,
We need to X up the top. How can we get up the top?
Times.
We can do that.
Swap.
Swap.
swap them.
Alright, there's 2 ways. You can times. But you can also do a flippity flip.
Flipping. Flip.
So as long as you flip both sides, all is good.
And then X take 5? I don't know.
Correct. Right, so you can flip. If, as Sarah suggested, you times by X plus 5 both sides, you will end up with that. It's just a few more steps. But you would end up with the same. Then take 5, as Sarah said, take 5. So 4 thirds minus 5. How many thirds in 5? 15.
Again.
So we've got 4 thirds minus 15 thirds. So how many thirds? Negative 11. Alright, that's a bit less than negative 4, isn't it? So negative 4's down there, a bit less than negative 4's there. And so we've then got something that looks like that. So in this case, this dilation of 4 has been taken care of by us finding those intercepts. Alright, because there it is here, there it is here in our calculation, yeah? So it's in the calculation finding the X-intercepts, it's already been taken care of. What do we know? We know there's another bit over here, so we kind of make it look, goes through there somewhere. And down here, and yeah, it's fit down there somewhere, something like that. And just kind of got to kind of try and make it look symmetrical. All right, so in that case, our dilation took care of itself. Others, we've got to look a little bit more into it. So let's do one more example. Alright, square root graph. So y equals negative of x minus 4 minus 5. So let's have a look. What have we got? There's 3 transformations. Alright. So if you're ever not sure, always just start with the x. What do you do first?
What was the question?
I said, if ever you're not sure about what the transformations are, start with the x and then go, okay, we're taking 4.
Oh, yeah.
So the first thing then is translation. Which way?
Right.
To the right. 5 units. Positive x direction.
4 units.
4 units, thank you. Looked at the wrong one. Alright, so we've done that, we've square rooted, and then we've got this minus here. What's this minus do? Reflects, yeah, I haven't mentioned that much. So reflection. In x-axis. And then the last thing, excuse me, last thing we do is we take 5. Which is a translation.
Wouldn't that actually be adding 5 if it was a reflection?
No. We do the reflection first
Right.
before we then do the 5. I'll go through the
That's,
steps in a minute,
yeah.
just to clarify what you've talked about. So it's translation, 5 units in the negative y direction. Alright, so over here I'll do this over here. Alright, so to go through all this, I'll go through each of those over here. So we'll start with our standard everyday square root graph, which goes like that, part of a sideways parabola. Yep. We then follow our transformations. It says translate 4 units in the positive x direction. So if I do that, means I'll move everything this way, yeah? So this point here gets moved to there. This point here gets moved to there. So we've now got that. Then after we've done this bit, we then reflect. So if we reflect in the x-axis, well, a bit that's on the x-axis, where's it? Stays there. So this point here, which was at 1, now becomes -1, yeah? So we had this point, the y value was 1, we reflect it down here to -1, and the same with all the others, and so we get this. Alright. Then, what do we do? It says take 5. So now we've got to take 5 off that. So the y value is 0, take 5, brings it down here. To 4 and -5. This point here, which was at -1, if we take another 5 off it, it comes down here to 5 and -6. And so we end up with that.
Oh, wouldn't it end up the same if you did it reflection or aspect? No, because it's reflecting over the axis. Right.
And it's to do with the, I know what you're saying.
Yeah.
You could say, all right, I know it's been translated across 4, I know it's gone down 5, so I know it's a point there. I then go, okay, it's reflected, it's reflected here, it's not reflected.
Yeah.
Yeah. So the order is, the order is the interesting thing. But if you did have something like, if I had something like this, for example, then that reflection
Is
after.
Right, there you go.
So with this one, you're going, okay, I've been translated to there, and so I'm doing this, but now I'm reflecting. So it depends on the order where the thing's done. So that's why I always say, rule of thumb, start with the x, what do you do to it first? You do your function. The function bits is kind of irrelevant.
Could you theoretically just go from left to right in the function? If it's, unless like without brackets, you could just go from left to right, so you could reflect it first.
In that you could, yeah, that one you could. But it's not always going to work.
Right.
That's why I always think, start with your x, translate 4, do me square rooting, reflect it, move it down. Whereas here, what do? Translate it, do our function, translate it, then reflect it. And very, very common multiple choice questions ask, which of the following could be a series of transformations of blah blah to blah blah?
Yeah.
And then they've got these lists of, and every time I look at them, my eyes go, oh, you just got to be really careful reading and getting the sequence right and all of that. All right, any further points of clarification, things we need to clarify? No? All right. 3F then.